All right, greetings. Today is Thursday, October 19th, 2017. This is a community meeting. It'll be posted on YouTube, so please be mindful that we're being recorded. And please go on mute if you're not talking. My name is Matt Bruzek. I'll be the moderator today. I work for the Scale and Performance team at Red Hat, and I participate in the SIG Scale. We've got a demo, some release updates, and some SIG updates today. So we'll get into it straight away. Phil, are you ready to present? Give your demo? Okay, I see a screen here.
Seeing stuff, but not hearing stuff.
I don't yet hear anything, but I see your screen.
The Kubernetes Zoom account is also muted. If you've pressed a button in the room, that's cool, but the microphone still shows a mute icon.
Right.
All right, can you hear me now?
I can hear you now. Yep, thank you.
Okay.
You should be a cell phone commercial.
Yeah, I know, Verizon, right, or something like that. All right, so I'm just going to give a quick demo of some concepts we've been exploring, and the goal is just to provide like tools that reduce friction when building APIs. So some of the things that it's targeting are making the Go vendoring libraries really easy and consistent. So you get all the transitive dependencies and don't have to pull those in yourself. Making writing tests a canonical way, really simple and easy. So automatically bootstrapping test stubs that provide like tests on storage and reconciliation loops to make sure they're run. And then making the development cycle easy by automatically spinning up control planes and that sort of thing for you. I'll just give a quickly on the status before jumping in that this is just a conceptual exploration. It's not a product. And so it's mainly looking at like, what could we do with tools? And it's right now it's built on API extension servers, which are different technology than CRDs, and a little more heavyweight. All right, so I'm just gonna jump in right here. So I have a terminal up. I'm starting out in this empty directory with a boilerplate. This boilerplate has a copyright in it, which will be appended to or prepended to all the files that are generated. So the first thing we do is we go run an initialization command, and this sets up the initial directory structure. I think it can't be quite. There we go. And you can see it sets up this vendor, so all the vendor files are right there, and you know, okay, this is a good set of vendor files. The second thing we're going to do is create a resource. So frameworks like Rails have commands that allow you to just create resources using a command, and it will generate a bunch of stubs for you. So we have something similar here. I'll run that. And then the last piece is to go ahead and run the server. So there's a bunch of stuff that's hidden, individual commands under this, but I'm just going to say run the server locally. This will spin up a control plane and generate a kubeconfig and allow me to talk to that control plane with the resource I just created and with the controller that reconciles it. So I'm going to pull up here just while this is building. So this is going to take a little while to generate all the code. So it has all the code generators packaged with it. It's going to generate clients and all these pieces. And then it's going to compile the API server, and it's going to compile the controller manager. And then it's going to run them along with that CD. So while it's doing all that, I'll just kind of open up the code that was generated. So this directory was generated with the types.go file here. And so this just has a simple stub that shows you where you can start dropping in fields. And it gives you a simple validate and a simple defaulting function. And these exist just so that when the server's running, you can see that they're run, and it has a nice like learning experience to it. These actually exist by default. So I could delete these and it would still work. You can see that they're appended to this foo strategy. And the strategy exists with empty defaults for all the storage strategy functions. There's also a test. This test actually works and actually goes ahead and stores the object and then reads it back out, deletes it, and then makes sure they're gone. So you can add right to this test right here your defaulting logic tests and your validation logic tests. It also builds a controller and corresponding controller test. And the controller just has this reconciliation loop, allows you to just start filling in your logic right there. If you like, this will give you a client set for the core Kubernetes client set and your APIs, so you don't need to set any of that up. And then also a controller test. In the controller test, the empty one just checks to make sure the reconciliation loop runs and fails if it doesn't run, but you can add, of course, logic here. The last piece this does, while it's compiling, is it generates an empty example for you. And so this will appear in reference documentation. And so you can fill this out with a specific example to show users how to use your object. So you can see here it's finished compiling, it's generated all the code, it's running an API server, and it prints out this little command that tells you to use a kubeconfig, and it prints out the API versions. You can see it has our API. You can run kubectl apply -f sample foo. So the goal here is just to make it really simple and easy so users don't trip over tasks that can be generated. So we go ahead and create an empty sample for you. So as soon as your API server is up and running, you can go test that like it actually works. You can see it works here. And I'll go ahead and build the docs. So I have this over here. You can see they just finished generating. This is what the reference documentation looks like. On the right-hand side, you can see where the sample got dumped. So if you update the sample, it goes in there. And it allows you to also run aggregated through Minikube. So the way I ran it just here was on its own, but I can do I can build configs to run it in aggregation mode. So apply-f config. So this will tell it to run again. I'm passing a build flag that says don't build it because I already built them. So it'll ask me for password since it's running on port 443. And then now it's running using my local Minikube instance and then actually running the local binaries on my machine or connecting to them. So now I'm doing kubectl so this time you can see I didn't give it a specific kubeconfig, it's just using the default one that for Minikube, and you can see it aggregated. And right here you can see the API showing up. It does a couple of other fun things that we're exploring, such as Basil support for Basil builds and using Gazelle to automatically generate the build files, which results in much faster development iterations. That's like down from a minute to build to sub-second. It also has some commands to build containers and run those containers inside a cluster, create sub-resources for you, automatically assist with listening, doing informers for objects in the core API, and other things such as that. So that's my demo. It's useful right now. You can see in the logs, it says defaulting fields, and then it'll print out, if I look back, running reconciliation loop for foo. So you can, it's actually kind of an easy way to explore the relationship between the API server, your controller, and how they interact with one another.
Can you cue crowd goes wild?
All right, that's all.
All right, well, thanks. That's great. It makes me smile to see stuff like that. And I imagine, can you put the link to the slides in the document today?
Yeah, I can go ahead and put a link to the slides.
Okay, great. Thanks. That looks great. All right. Well, we'll go to the release updates right now. 1.9, Anthony, do you want to unmute and tell us?
Hi, this is Anthony. So we're just going to getting started with the 1.9 activities, trying to get together the team for the first release team meeting next week. I've started a thread on the SIG release mailing list, so if you're not on there, please go look for that if you're in the release team. Other than that, next week we're going to, according to the proposed schedule, we have feature freeze coming up, so I'm going to send an announcement for that. That's where you need to have, if you're trying to put a feature into 1.9, you need to have the issue opened with all the fields filled in on the features repo. And then lastly, we're trying to target the second alpha build also next week.
All right, any other questions or any other updates? All right, we'll go on to release 1.81. Jace is out. Does anybody want to give an update for that in his place? No updates. Okay. How about release 1.7.8? Is there anybody here that wants to give an update on that? Uh-oh, we're going too fast. George isn't going to ask me back to moderate anymore. All right. All right, so with that, we're going to go to SIG updates about 15 minutes early. So Aaron, you have the floor and a lot of extra time.
Awesome, because I'm literally still working on my slides. This will be great, everybody. I'm incredibly prepared. So
saying you haven't run the tests in the slides yet.
yeah, we'll do it live. So back in like mid-September, I had started to draft slides to sort of brag about all the awesome stuff that's happened in Q3 for SIG testing. I'm going to try to abridge that. I'm going to try and walk through a couple demos of things. So some of what I say may not be the state of today. And if somebody knows about that and can correct me, I greatly appreciate it. And with time at the end, I will just sort of hand wave roughly where SIG testing would like to head in the 1.9 time frame. So with that, I posted a link to slides in the doc. If you can't see them, just let me know, and I will like I will turn these into something that's a little more finalized. Okay, I might need to adjust permissions. Yeah, so let me just, I'll show the slides now, and I'll fix the permissions after the fact here. Okay, so I'm gonna share screen, probably this screen if I've done it right. Okay, cool. So I think we can see.
Yep, I can see your screen and I can see the slides.
All right, can I click play? Present, hey, that's the present button. Awesome, all right, so update by me. We have a Slack channel. I consider SIG testing Slack channel to be a pretty fun place where we really live and breathe testing day in and day out. So like I said, I wanted to roll through some of our 1.8 accomplishments. Eric Feta did a fine job of laying most of those out in post to, I think, the contributor experience mailing list, and I believe it also got CC to Kubernetes dev a couple weeks ago. So maybe this is all old hat to many of you. And then we have a Google Doc with most of our planned issues that we're going to chew through for 1.9. I'm in the midst of turning those into GitHub issues and adding those to the v1.9 milestone in the Kubernetes testing for repo. So just walking through a couple of the things that are in 1.8. We now have a project called Bastas, which is basically in charge of leasing GCP projects from a pool of empty GCP projects. Many of you probably weren't aware that in the bad old days, about 4 months ago, we had to have a Google Compute project per job. So anytime somebody wanted to add a new job to our CI infrastructure, they had to go bug the right person or figure out how to get a new Google project and then figure out how to like tune that and make sure everything was set up correctly. And we now pretty much just check out a project from the pool, run the, stand up the cluster in there, run tests against it. If the project has been checked out for too long, it gets reaped. If the project didn't get cleaned up appropriately by the tests because they exploded mid-run, there's something else that'll go back and clean that up. And projects are generally cleaned up before they are put back in the pool. So Sen put this together. He did a presentation at SIG testing a little while ago. One of the things I personally liked a bunch is that right out of the gate, he made sure there was a dashboard so you could see what Bastas was doing in terms of the number of projects that are dirty or free or available of different types. And you can sort of see there are little gaps here. So here, for example, where something maybe kind of went wrong. Maybe Bastas went down, maybe we were having infra-related issues, but you could pretty quickly see that, like, if all the jobs were failing for some reason, it might be because the number of dirty projects went up. And then when we fixed the problem and redeployed, dirty projects all got cleaned and we were sort of back to steady state. I love being able to see steady state. Okay. Kubernetes, you probably all have interacted with this at some point, day in and day out. It displays test results from various jobs. So here's an example linked to the Kubernetes page where I wanted to highlight a couple of the new things that have happened lately. Where did that string came from? Well, it came from this particular test. That's cool. If I want to see the standard error or standard out of the tests as they were running, instead of having to go click on build log and look through like 12 to 16 megabytes of stuff, I can just click down here and it will expand and I'll actually get to see some of the logs from that particular test. If I scroll down way further, because that's a lot of logs, I can also see all of the tests that were skipped in this particular run. And I can also see all of the tests that passed in this particular run. I can also, up top here, see that 2 tests failed, 333 succeeded. Most of these are improvements that came from either Clayton Coleman from Red Hat or Ryan from Google. I can also click this button here to see recent runs of this particular job, although test grid kind of does the same thing, and I'll get to that later. It also kind of works from a pull request perspective. So let me just go to an arbitrary pull request here. Let's look at one that's failed for whatever reason. So just while I'm here, a number of people will often ask, like, what are the jobs that are required for a pull request to get merged? And all of the job names down here have a word required next to them that indicates which of the contexts are required for merge. There's also a context here by the submit queue, which will also tell you like what it thinks the next concrete step is. So in this case, it knows at least one test that's not green right now, but it'll also update this if it needs, like, if the pull request needs to be rebased or if somebody needs to add LGTM or the label. So I'll click through on the details here to get to a Kubernetes page. So, all right, this looks pretty familiar, right? If I click on this pull request number, then I can sort of see the history of all jobs that ran for this particular pull request. And so I chose a poor example, but if I found something that had been tested over time, I would see these results sort of march out with various greens and reds as we move on. It's a really handy place to see results for all jobs that were kicked off from your pull request. All right, and I lost my slides already. Look at that. We're doing great here. Good thing I have those extra 15 minutes. Okay. Kubetest, the only thing I want to talk about with Kubetest is it's basically the standard tool for how we stand up clusters, run tests, collect results from those tests, and then tear the clusters down. To date, it's mostly been used in the context of end-to-end tests, so standing up a cluster and running end-to-end tests against it, but we've recently been adding support for things like standing up multiple clusters at once to support federation testing. And we've also recently added support for running node end-to-end tests as well. So our goal is, for those of you who are familiar with hack-e2e.go, it's just a shim around downloading, like, go getting this and running this. So we've sort of migrated away from a bunch of as much horrible bash as we can to something that's actually written in Golang. And there are different sort of plugins or deployers that can be implemented for more than just the scripts that live in the cluster directory in Kubernetes. So there's one for Kubernetes Anywhere, there's one for kops, there's one for GKE, things of that nature. Some of you may be familiar with Basil. I still don't know how to pronounce it, sorry. It doesn't have the greatest cross-compilation story right now. It's way, way better than it was 3 months ago, and we're rapidly hoping to move towards a world where it's the de facto way of building and running Kubernetes and all of the tests and infrastructure around Kubernetes, because it does a fantastic, magical job of caching everything and running only what needs to be run. Ben the Elder from the GKE Engprod team put together this script called Planter, which is basically just a shell script around running Basil inside of Docker, and it definitely works on Linux and Windows. Sorry, Linux and Mac. I believe it also works in Windows, but not, like you can't run Basil natively on Windows. And it's definitely exercised against Kubernetes and Kubernetes test infra. We are very interested in data-driven decisions and metrics about our tests. We have a program called Kettle, which is basically responsible for scraping all of the test results that are stored inside of Google Cloud Storage buckets and turning that into something that gets stuffed into a big query data set, which we can then use to generate useful metrics. Cole Wagner recently updated the set of scripts that we use, so I can show you this wonderful dashboard and ask you to help out. So the two graphs up here, I wish I could better articulate the math behind them. Essentially, if you want to know the nitty-gritty of what these mean, please come to the SIG Testing Slack channel, where you two can scream about statistics and test results. But essentially, these roughly show the chance that any given single pull request or commit will flake arbitrarily. And when I say flake, I mean same commit passes or fails continuously. So anytime somebody like slams retest without actually updating their pull request, that's going to count towards this. Anytime somebody continually adds new commits to their pull request, that doesn't necessarily count as flaky, because their code could have legitimately failed because of bugs. So a good thing to see here is that these lines have generally kind of calmed down a little bit and are starting to go down and to the right. We like that a lot. The thing I really like calling out here is the flakiest PR jobs for the past week. So I can see which job has been the flakiest across all pull requests. And then within that job, I can see what's the most flakiest test and what is the second flakiest test within that job. So if anybody out there wants to help with the stability and velocity of the community as a whole and wants to know what's the flakiest test that the most people are running into, it's this one. It's at the top and it's at the left. If you want the next one after that, you're going to have to do some math, but it looks like the GCE Basil job is most often failing with this SIGApps related job. So if you are a member of SIGApps and know what the test is that ensures that jobs should run to completion when tasks sometimes fail and are not locally restarted, you would be a super awesome hero if you fixed this test. You would reduce the number of flakes and more of us would get our code merged more frequently. Next two tables down here show the longest failing PR jobs, the number of days they have been failing in a row. Many of these are not actually blocking PR jobs. We're trying to move towards a point where all of the PR jobs that are run per PR that are considered blocking. Remember, it's the ones I said have that little required label next to them. Like, we want to try and get non-blocking jobs just to not report periods, since that seems to really confuse people. And then the longest failing jobs, we would eventually like to come back and start to make this table useful, because it seems that jobs that have been failing for 227 days are probably not providing much value to this project. And if nobody's actually taking the time to fix them, we probably shouldn't take the time to look at them either. Okay, Munch GitHub. Munch GitHub, I have talked about this before. It's the thing that sweeps through GitHub and pulls things and then does things to them. It's deprecated. No more Munch GitHub, only Prow, please. It still does kind of a number of things. So we have this issue here where the functionality that each munger has, we are attempting to re-implement as either a Prow plugin or a standalone program. So the issue that I linked in this slide, which you will be able to see in a little bit, or if you go to the test info repo and look at the V19 milestone, we're tracking how we can move all of these things away from Munch GitHub and over to, excuse me, Prow. That said, I will go back to Grafana real quick and show that we do have metrics on Munch GitHub still. So we split up Munch GitHub into two, at least for the main Kubernetes repo, we split that up into the submit queue instance, which is the one running in green, and the MISC Mungers instance, which runs everything else. So like Blunderbuss, responsible for assigning people, approval handler, responsible for putting that comment that says who has yet to approve your pull request, closing stale comments, putting the needs rebase label when a PR has been updated or when a merge happened that caused that PR to need a rebase. Like all of that stuff is run in MISC Mungers. So that's less important to us than making sure your code gets merged as quickly as possible. So you can generally see here, like this little notch over here is what happens when we come out of code freeze and we suddenly get slammed with a ton of pull requests to merge at some point. And the submit queue really takes its time hammering the GitHub API, but we gradually sort of come back up to steady state. You can see there was this nice big hump here of working through all of the queued pull requests and actually getting them merged. And lately, we've actually come to a nice sort of steady state looking thing where turns out Kubernetes seems to be worked by a lot of day job people because we have a pretty nice consistent Monday through Friday hump of merge pull requests. Okay, same story with Jenkins. If you have any issue, I won't click through to it, but hopefully we're doing the right job of reaching out to people who still have jobs that are running on Jenkins. We would like to end of life Jenkins by the end of 1.9 or shortly after the 1.9 timeframe. You may not be aware there are like 100-ish Jenkins slaves responsible for executing a bunch of jobs right now. We would really like to bring that number down. Jenkins is significantly harder to manage than a Kubernetes cluster, which is what we use for Prow. We are highly motivated to help unblock you. Generally speaking, the jobs that are still on Jenkins are jobs that are tricky or corner cases or might not be easy to move off. And we want to identify those blockers and help accomplish that. So I just chatted with SigScale this morning to make sure we're on track for moving the scalability and the kubemark jobs off. So this thing Prow that I keep talking about, it's the thing that's responsible for handling GitHub events and doing all the bot commands for Kubernetes that you know and love. It's got a pretty decent README here that explains the various sort of microservices that implement Prow. We now sort of have an announcement section because we have folks from OpenShift and folks from Istio who are also using their own deployments of Prow. So we are starting to try and make sure if we break things or change things that people are aware of that. If you would like to get started using Prow on your own, there's a document here that describes sort of how to use GKE to turn up a cluster, run Prow in your cluster, modify plugins file to enable certain plugins for your repos of choice. So I believe this is also being used by the TensorFlow team, if not now, very shortly. I'm probably running long on time here, so I'll just say these were things that were described in Eric's email. If you put a /hold in your PR, a do not merge label will be applied to your pull request. Similarly, you may have in the past put up a pull request that's like a work in progress, but you just want to see the bot run tests so you can see how it's doing there. And you might have prefixed that PR with WIP or put it in brackets or parentheses. We'll have a plugin now that automatically notices that and will apply a do not merge label. And it will also notice if you change the pull request title and remove the do not merge label. So you kind of have a little bit of power of holding your PR back, but still getting it exercised by our CI system. And we also have the ability for Prow to send messages to Slack. The most effective way we found to use that right now is to message the Kubernetes dev channel whenever somebody manually merges a commit. We would anticipate that manually merging a commit as a human is a really extremely rare event. Generally, if we're doing this right, We're making sure that all the automated testing works, and it's the automated testing that merges stuff. We are identifying there are cases where this falsely triggers, so release coordinators who are manually merging in or doing cherry picks, that seems to trigger it. Trying to revert a pull request through GitHub's UI, that seems to trigger it. And we'd appreciate help in reducing the noise in this to make sure that we do appropriately notify and say, hey, this is kind of unusual, versus, hey, this is just, the release manager doing their job, fast forwarding a branch or something. I don't have too much time to talk about this, but I'll just say that we are planning on replacing the submit queue. It's slow, it's really complicated. There's a lot of questions about what is it doing? Where is my pull request in it? We have a high why is everything serialized? It certainly seems like we could be merging multiple things at once. I will again just sort of defer to, we have an issue in test infra. We have turned on a replacement for the submit queue in the test infra repo. It essentially uses GitHub queries to say, hey, what are all the pull requests that seem like they've got the right labels on them and all the tests seem to pass and it looks like they are cleanly mergeable. Can we just like gather up all of those and just get ready, run the tests one more time and then merge those? This describes how it's done in a batch as well as serially. This supports doing multiple repos, not just Kubernetes with one deployment. And this supports multiple branches at once, which should play nicely with the desire to start using feature branches for development. And once I share the slides, you can also click through to the design doc, which sort of describe the motivations for why we think the existing submit queue is not that great and we wish to remove it operationally. Test grid is probably my favorite thing from this group. It may look a little different than the last time you've seen it. We now have, I think they're called tab groups or dashboard groups. So here are all of the dashboards that belong to SIG testing. Here are all of the dashboards that belong to SIG release. My favorite dashboard is the pre-submit dashboard. Here are all the pre-submit jobs that run for Kubernetes. I'm looking at the summary tab right now, which has little icons that show which jobs are considered flaky, which might be normal for a pull request job, because pull request jobs aren't going to always pass because people aren't always going to submit perfect code. Which jobs are failing consistently. Looks like the Kubernetes GCE job is failing. And hopefully there's a passing. Look, cool, Node E2E has actually been consistently passing over time. And if I click through to that, I can see it'll take a little while, but this shows like the past 24 hours, I think, of test results across all pull requests. So I find this is generally an easier method of displaying this stuff as opposed to Kubernetes. So many more things, and I think I'm really running long here. I could also, instead of that summary tab, I could take a look at this little box here. You can probably squint and imagine how if I embed all of these in divs or iframes, I could quickly get a grid of like, what's the general stability of all the tests. Our pre-submits are pretty flaky right now. I have in the past seen a lot more of them green. So it seems like if I were to just quickly say our project's a little unstable or it's more unstable than it was a week ago. We're also going to be using, I think it supports it, but I don't know how to use it yet. The concept of having test grid email you if your test is failing. So if you have a test that's definitely pretty consistently green and it suddenly goes red and you want to be notified of that, we can have test grid email you. And that's something that you can configure. You can click through on this README to find out. I'm going to skip over that one. Finally, triage, sort of an alternate view of if I wanted to fix something, what's the most important thing I could fix? This basically attempts to cluster together failure text from all different jobs and all different test cases. So you can sort of see it's sorted by quantity. So this is generally speaking the test failures over the past week. And then as I scroll down, I can sort of see particular test failures. I'll just pick this one, expected endpoints map, got net server 1. I can see which jobs it failed in. Sparklines aren't really telling me that it's separated to one job. Just most of the GCE, COS dev, COS dev jobs seem to be having issues with this. And they've been having issues with it pretty consistently over the past week. So this is another place you can quickly see, like, in aggregate, what's a test failure, when did it start, where is it happening. This might help you quickly triage or isolate where to go next for troubleshooting. Okay, so I think you got the message that for v19, we'd really like to end of life all the things. Well, we mainly just want to end of life Jenkins and Munch GitHub. We'd also really like to end of life submit queue and turn that into Tide, which is just another Prow plugin. We'd like to support a set of very well scoped things. We'd like to have more of a support policy in place to make sure that if the submit queue is broken, what's the escalation policy look like? Like, who do you contact first? How do you know they've acknowledged that contact? How do you know that the problem is being worked? How do you know what's happening next? We have been in talks with Jay Singer-Dumars to put together a document. Look for things like a status.kates.io page. Look for things like more active people in Slack. Look for potentially a label that gets added to certain issues that denotes them as we really have to drop everything and work on this right now. Look for a testing ops channel in Slack where alerts will start going from various pieces of our test infrastructure if we notice that it's starting to get unhealthy. So instead of humans having to proactively look at the submit queue and various other dashboards, we could actually have alerts sent to that channel if conditions are met. Look for just general operational transparency in general. I love dashboards. I love seeing how it's all working and what the steady state looks like. And we'd like the rest of the community to be able to see that as well. And finally, we'd really like to enable more support by non-Googlers. I mentioned earlier that Istio and OpenShift are using this. So we have a community of people who are knowledgeable about the infrastructure that drives Kubernetes. But at the moment, they can't really actively support it because this is all running on infrastructure behind Google's walls. And we are working with the CNCF to find a way to open the pool to people who are interested and are trusted to actually help go on some kind of, dare I say, on-call rotation to make sure that the project is flowing smoothly. Any questions? Too bad. I think I've really blown through time. But no, seriously, I'll take any questions unless Matt says we should move on.
No, I think we have time for questions. Let's just do that.
Joe.
Anybody?
Yeah, so Aaron, I think, what are the opportunities to actually tie tests and status closer and closer to SIGs, right? I think, it seems to be like an opt-in thing for a SIG to adopt a set of tests. But I think, one of our pushes that we've been talking about is to create stronger sense of ownership of SIGs over any sort of artifact or code or whatever. And I feel like, hey, if something's broken, can we actually tie that back to a SIG and keep track of like which SIGs have the most tests and the flakiest tests and all that, and really try and make the responsibility land there?
That's a really good question. I think where we're at today, if you notice when I was touring through test grid, is that each SIG has their own dashboard. So there's nobody really standing over top of all the SIGs or SIG leads or whatever saying, why isn't your board green? What's going on with your board? I did show you how there was a dashboard that said they're the flakiest jobs and then the flakiest tests within those jobs. And there was a fix-it within Google a couple of months ago to just sort of like ad hoc add text tags to the tests. So you notice I called out SIG apps as owning the flakiest test for the flakiest job. Now, I don't have the power to go just constantly say like, why haven't you fixed this yet? Why haven't you fixed this yet? I'm not exactly sure what the tactful way of doing that is, but I have been just gradually pointing out how if other people want to go ask them why their pull request isn't merging because that particular test has yet again failed.
I'm not thinking necessarily around shaming just as much as like there's a ton of tests out there that aren't strongly associated with a SIG. And those dashboards in terms of what they cover, we don't have perfect coverage or assignment of like, tests to SIGs, right? So I think just getting sort of a stronger relationship there might actually help move this forward. I don't know, it's one idea.
I mean, we definitely want all tests and code to roll up to SIGs, so we should do that. With respect to the showing the flakiest tests, I think it would be useful to review various metrics at this meeting on a regular basis, and we should figure out what those metrics should be, and maybe we'll have to rotate because there are so many metrics. But between these test metrics and the new DevStats dashboard, we're going to want to start improving on various APIs of the project. And so reviewing them at this meeting on a regular basis is going to be a critical part of that.
And I think, you know, I totally agree with Brian. I think that's a great idea, but I think having those things roll up to something that feels more personal versus like, hey, there's a test that's failing, like, you know, not my problem, right? If it lands on a SIG that you're closely associated with, it starts feeling like, hey, maybe that's something I should actually get involved.
Yeah, I mean, I think we don't really yet have a policy in place that mandates that if a test is failing, that a SIG has some sort of SLA that they have to fix that test within a certain time, right? Just like we still have baby steps for how do you even escalate and make sure that the submit queue being blocked entirely is broken, let alone like an individual SIG's test is getting flakier than we would like. And
I think the first thing is getting that association down, right? And then we can figure out whether there's an SLA and how do we make sure that people actually sort of get on top of it. But we don't even have that assignment right now.
Yeah, I think one thing that usually helps with setting SLAs is also to understand the historical SLIs. So if SIG testing could actually do some analysis of like so we have some sense of what kind of SLA might be reasonable, then I think the next step would be for SIG testing to actually propose the SLA.
Okay, that might be fair. I can't necessarily speak for the bandwidth that we have to accomplish that right now, but I definitely like the spirit of that.
Yeah, but definitely keep it in mind. I think, you know, there are a number of horizontals of the project: testing, release, docs, etc. It's going to be the responsibility of those groups to actually propose what policies are needed in order for the project to be healthy for that.
In terms of baby steps, I wouldn't mind seeing that applied at the job level first before we start going to the granular test level. So we have some sort of general notion of, like, I think in our heads roughly, that a pre-submit job that is run for every pull request and blocks every pull request for merging is something that probably should run in less than an hour and should probably be pretty non-flaky for some value of non-flaky. Similarly, for getting a release out the door, we have a bunch of tests that in theory should have all been passing before we cut bits. We've ignored that in the past. I would really like to call that list of tests down, that list of, jobs, I'm trying to use job terminology here, down to a useful set of jobs that have actually proven that they pass within a certain threshold of time and they can pass at least n times in a row, something to that effect. Because that's the sort of ad hoc criteria that the release team has used to cut releases in the past. So, I mean, a concrete example of where this ballooned and bit us in the past was, you know, a 5,000 node scalability job that hasn't passed in 2 months doesn't seem like it's a useful candidate for blocking the release. Similarly, we've had noise in the past about how the cops job doesn't seem like it's a useful candidate for blocking all pull requests if nobody's going to fix it within 24 hours of it breaking, right? And so, like, organically there, we got collaboration within SIG testing and SIG AWS to make sure we better understand that job and it's more actively maintained. But I think just at the job level, we should start with those SLAs before we start going to the individual test case level. But I agree with regular, you know, pointing out of the top 3, say, like when Eric was mailing out regular reports of the top 3 flakiest test cases and then going out as a human being and talking to those people. Was that actionable? Did that accomplish stuff?
If you can write down some of these guidelines, like these kinds of jobs should run for no more than an hour, these kinds need to be 99.99% non-flaky, things like that, I think that would be a good start as well for informing decisions about what jobs are made blocking versus merge or releases or whatever.
Cool.
Okay. Sounds like you have a good intuition for that already.
We've got to move on here.
Sorry, I'll just say I'll do that with my CI signal hat as a member of SIG release. So look for a proposal from SIG release on that.
All right. We've got to give the SIG storage some time to give their update. I'm sorry. We can go on to that. Michael, are you ready to go?
Talking about it, and we're thinking maybe we'll just skip for next week because we had like a 50-person, or actually including GVC, like 80-person GVC, and a 2-day session that had a lot of good things going on. And we want to make sure that service catalog also has time. So it probably makes better use of this meeting time to give them maybe 10 or 15 full minutes, and then we can go and give like 10 or 15 minutes to storage next week. That sound okay?
Yeah, that sounds great. So you want me to move it to next week?
Yeah, if that's all right.
That's fine with me. Okay, thank you. Thanks for yielding your time.
Oh, no problem.
The SIG service catalog, Paul, do you want to go?
Yeah, sure. So I'm going to look very underprepared by comparison. This will probably take maybe about 5 minutes. So just a quick recap, if anybody is not familiar already with what Service Catalog is. Service Catalog is an integration between Kubernetes and the Open Service Broker API. Open Service Broker API is the descendant of the Cloud Foundry Service Broker API. And what a service broker is an entity that that handles provisioning. Well, it offers a set of capabilities called services. Services can have many plans. A plan is a tier of a service. So the service broker is something that presents a certain set of services and their plans. You can, using the service catalog, provision new instances of these services. You can update, like change plans if the service is plan updatable. So say you start out on a just like a starter plan, maybe with some low performance characteristics of whatever your service is, and you want to, after you make the front page of Hacker News or Slashdot, you want to move up to a more higher level plan that gives you more performance. That's something that you can do. And once you provision an instance of the service, you can get credentials to use it in your application. That's called binding. And when you're all done, you can unbind from it and deprovision the service instance. So just to drive that an example home quickly, the canonical thing that we point to for this is like a service might be a database as a service. So when you provision an instance of the service, now you've got your database that you can use. And when you want to start programming it against your database and use it in your application, you make a binding to it. That gives you back credentials that are put into a Kubernetes secret, and then you can use them just like anything else that's in a secret. And that's essentially what it is from a functional standpoint. Now, the interesting thing about this project is that it is an extension of Kubernetes that is shaped like Kubernetes. So there's an API server and a controller manager that backs the API server. And it's been really fascinating to see how things have progressed over the last, it's been about a year since we started the SIG and started working on the incubator repo. Things have gotten quite a bit easier, and things like kubectl have come a long way to supporting resources that aren't part of the core. So I actually will be able to give a demo sometime very soon. There's a demo on the incubator repo site, but it's a little out of date. I'm planning to re-record it now that, and here's, I buried the lead. Here's the big takeaway here. Now that we're getting ready to publish our first beta release. So recently in the SIG, over the last several weeks, we have started publishing release candidates for our 0.1.0 release. The last one was on Monday. It's release candidate 2. I think it's likely that we'll maybe cut one more either tonight or tomorrow morning. And we're shooting to release a final 0.1.0 release in the next couple days. I would love to have any feedback if folks can try it out and report issues or bugs. And that's pretty much it from us. I want to thank everybody that has contributed to that project, both inside the SIG and inside the incubator repo. And then a lot of the things that the API machinery SIG has done, a lot of things that SIG CLI have done, have really helped us out. And I just want to thank everybody that's contributed in whatever way, either code or reporting bugs. So thank you very much, everybody. It's really appreciated. That's it from me.
Okay, great. Thank you. Thanks for the concise update. Do we want to go back to storage to give a teaser for next week, perhaps?
So we met last week. It was kind of an interesting SIG face-to-face We had never really had more than maybe 20 people in a room. We had 50 and we had to cap it at 50. Thanks to Paris for finding a room, which was the reason why we had to cap it. I think the interest of what's been going on lately has been sort of phenomenal. We probably could have gotten like 80 people coming to the face-to-face if we could have found the capacity for them. It's just something that we're gonna address for the next one. The agenda items, you know, they came from a large range of things that we've got linked in the community meeting. But I think the biggest one was CSI and out-of-tree plugins, which we discussed at length. I think we did take a lot of time explaining to people why it's not done yet and why it can't be done by the end of the year, just because there's a lot of interest from vendors and users on that. Brad, is there anything you want to hit before the end of today, just that you thought was another big highlight?
No, nothing specific.
Yeah, so you know, there's a rundown of issues or just topics, and each one. I think this was probably one of the most well-run face-to-faces that we had. Usually we run out of time, and this one we managed to cover everything. A lot of this had to do with the fact that we sort of set up a polling system of what people wanted to talk about before the agenda and had voting done all within about 5 minutes of meeting. We discussed local persistent storage and got an update from Michelle. There's a lot of work in being able to treat the local disk in the same way as a first-class citizen, and now we're integrating that with the scheduler. I'm just going to run through the agenda items pretty fast and then let people ask questions. Block storage was presented by Aaron Boyd, and this again is how we are not just relied upon on the Mount and the POSIX API, but also looking into how to get raw blocks into the system and how to do this securely, which is probably one of the biggest challenges. Snapshots, I think, finally got over the hump of use cases that has been challenging it for the longest time. Jing and a whole bunch of people have been working on this for a while, Jing, Brad, and more. And I think that I'm hoping in 1.10 we'll be able to get it into alpha. And so that we'll be able to finally, we found, I think, the tight use case where we easily could have made a complicated API for snapshots. Jan has been working on containerized Mount utilities for 2 years, maybe longer. And it looks like we finally got through both the work that had to be done in this SIG and I think Node SIG and others and all the other approvals needed in order to get this functionality into Kubernetes. Again, you can see here on the community list, there is a bunch of YouTube links. For some reason, I know that some people have sat down who couldn't make it and listened to all 2 days worth of the talks. So there's, some big eyes in this room, at least at the surprise of that. I know at least a few people, some of them who are not related to anyone who was in the room, who actually did listen to the 16 hours of discussion on storage. We also talked a little bit about other things going on in the Node team that do affect what's happening. But I think the big thing and the takeaways to have from this, we can get into more detail next week, is we are seeing a large uptake of interest from 2 groups of folks, the vendors and startups that are showing up and want to make sure that they are container ready for storage and Kubernetes ready. And also a lot of folks who were previously involved in OpenStack have found that this was a good place to go, both for the future of OpenStack and I think the future of sort of infrastructure overall. And I think storage plays a large part in that. The other one was, it was a very good, I was very worried about the sheer size of folks who would get in that room if we could have an order discussion. And I feel that not only were we able to go through the technical details and benefit from all of the people from many different walks of life in the room, but we were very much able to get out the Kubernetes message across. So, while some people were very concerned about the details of storage backends and how to expose that to the user, I think that the message, and I think one that we need to continue really spreading overall, is the idea that we should really focus on the application and the pod needs, and make sure that we represent the users even though they're not always in the room. And that is really a guiding force to solve some of the harder, trickier edge cases that we have. We definitely encountered a bunch of them, especially regarding stateful sets and self-healing storage systems that we know are still unanswered. So there's just a ton of work going on, and you just go take a look at the list and you can see a lot of new faces that were in the room, new companies that were in the room. And it was great because some of these new faces and new companies already knew about Kubernetes and had played with it in ways that maybe those of us developing it hadn't. So it was, I had high hopes and they were exceeded for this event. I don't know if anyone else has anything to say. It would be neat just to go to the YouTube session and see if there's something that interests you and just click and hopefully you'll find, good, healthy example of, cool SIG discussions going back and forth.
Yep. Okay. Well, that's great. There's links on the community document to those. I want to get to announcements before we end. Is there anybody, any last minute announcements before we go? I see two of them, George and Paris, if you want to go.
George, you go. Or not. Let me give you an update for.
All right, Paris, I'm going to let you go first.
All right. Outreachy has officially launched. For those who don't know Outreachy, it is a program that pays stipends to interns who may be underrepresented in the open source community. It's a great program and worthy program. This is the first time that Kubernetes is a part of it. We do hope to continue. We did get in during the witching hour though, so we did only have one SIG participate, that's CLI. Phil's actually going to be mentoring, and we're going to be picking one intern. We already have several applications, and it's only been live for a few hours. So it's definitely a popular and worthwhile endeavor for us. CNCF is actually paying, and this is also their kind of beta test, if you will, to see if this would work within Kubernetes. So cheers to that. Also, Contributor Summit invites are definitely going out today, including the lottery. So look out for that.
One last moment. Just one thing I forgot to say thank you to is for Dell EMC for funding dinner and a lot of the other parts of the event.
Okay.
And they've been doing that for a long time.
Great.
And Portworx for breakfast.
Yes, thank you. And Portworx for breakfast.
All right. George, did you have anything before we go? We have 2 minutes. Nope, he's good. Office hours next week. So, all right. Well, I wanted to thank the note takers, Ryan and Josh. Please thank them for taking such great notes. There was a lot discussed. Sorry I had to cut the testing one short, but we wanted to get through everything. So I think that's it. Everybody have a good week, and we'll see you next week. Bye.
Thursday.